In this video, we'll take a look at plane polarization and diffraction specifically for EDEXCEL. We'll take a look at specification point 82, which states that we need to understand what is meant by plane polarization, and specification point 83, which states that we need to understand what is meant by diffraction, and to use Huygens construction to explain what happens to a wave when it meets a slit or an obstacle. So, let's say we have a wave oscillating vertically, and we have a polarization filter on the right hand side. Since the filter's slit, which is represented by the following blue line in the center of the filter, is aligned with the vertical oscillation of the given wave, then all of that wave would be transmitted through. Now, if there's a case where basically we have a wave propagating horizontally, as soon as the wave reaches the filter, none of that wave is transmitted. And this is due to the orientation of the filter being perpendicular to that of the horizontal oscillating wave. Now, if that filter were to be moved through 90 degrees, then all of that horizontal oscillating wave would be transmitted through. So basically, plane polarization can be defined as a process in which vibrations of electromagnetic radiation, especially light, are restricted to one direction. Moving on, we need to take a look at what Huygens construction is. So Huygens construction states that every point on a wavefront may be considered a source of secondary spherical wavelets which spread out in the forward direction at the same speed of the wave. And the new wavefront is the tangential surface to all of these secondary wavelets. So as we can see on the following diagram on the right hand side, we have our initial wavefront represented by the first black line, and on that first wavefront we have points or sources of secondary spherical wavelets, and those secondary spherical wavelets intersect and produce a new wavefront, which is represented by the second black line, which is tangential to the surface of all of those wavelets, and that second wavefront will basically propagate with the same speed as the first wavefront. Now, Huygens construction or Huygens principle can be used to explain what happens to a wave when it meets an obstacle. So assuming that the wavelength of the wave is much smaller than the gap of the obstacle, as the wave reaches the obstacle, it will either be reflected or absorbed. As the plane wave reaches the gap/opening, specific sources along the plane wave will emit spherical waves which will move outward and produce a new wavefront. And the ability of waves to spread and move around the edge of obstacles is basically known as diffraction. Thank you all for watching. I hope this video has cleared any questions on plane polarization and diffraction. Thank you and goodbye.